Hello friends, continuing with the topic electric dipole. Today we discuss about electric field intensity due to an electric dipole at any point on its axial line and its equatorial line. Axial line and equatorial line. Before we proceed for electric field intensity, let us understand what is an axial line and an equatorial line of electric dipole. Now first we take up axial line of dipole. How we define it? It is the imaginary line joining negative charge minus q and positive charge plus q, minus q and plus q, and is defined as the axial line of the dipole. I repeat, imaginary line joining negative charge minus q and positive charge plus q is defined as the axial line of the dipole. Now look at the diagram. The dotted line is the axial line of the electric dipole. Now we define equatorial line of the electric dipole. The right bisector of the line joining negative charge minus q and positive charge plus q is defined as the equatorial line of the dipole. Now this is the right bisector of the line joining minus q and plus q, so it is the equatorial line of the dipole. Now after understanding about axial line and equatorial line, we take up electric field intensity due to an electric dipole turn by turn. First we take up at axial line of the dipole. Now we talk of electric field intensity due to an electric dipole at any point on its axial line. First point, we develop physical situation. Consider an electric dipole consisting of two charges plus minus q and minus q, separated by a distance 2a, separated by a small distance 2a, such that its dipole moment p is equal to q into 2a. Mark it as equation 1. Now let P be any point on axial line of the dipole on the side of plus q at a distance d from the midpoint of the dipole, where electric field intensity is to be determined. Okay. Electric field at P due to plus Q. How we write the expression for electric field at P due to plus Q? Say E plus equal to K naught Q divided by D minus A whole square along axis of the dipole. Why D minus A? Because P is at a distance d from midpoint of the dipole and plus q charge is a distance towards P. So the net distance from plus q of P is equal to d minus A. Now at the third step, we write the expression for electric field intensity at P due to minus q. Say E minus, this is E minus equal to K naught Q divided by D plus A whole square. Why D plus A? Because point P is at a distance D from midpoint and another distance A of minus Q from midpoint on the opposite side, so it comes out to be D plus A. The direction would be opposite to axis of the dipole. Now resultant field at P. its vectorial sum, linear vector sum we have to take. So E axial would be equal to E plus E minus. So E axial is equal to E plus E minus, the linear vector sum. Now angle between E plus and E minus being 180 degree. Therefore, E axial will be equal to the subtraction of the magnitudes. That is, E axial will be equal to E plus minus E minus. So let us mark it as equation number 2, and direction would be along axis of the dipole, because E plus is more than E minus, and the subtraction direction will be along E plus. Now substituting the value of E plus and E minus in equation 2, we get E axial. We get E axial is equal to K naught Q divided by D minus A whole square minus K naught Q divided by D plus A whole square. You take out Q common, and we write here K naught Q into 1 by, within bracket, 1 by D minus A whole square minus 1 by D plus A whole square. On simplifying, we get E axial is equal to K naught Q within bracket divided by D square minus A square whole square, and in the numerator we write D plus A whole square minus D minus A whole square. Okay, or equal to it is equal to K naught Q 4AD divided by D square minus A square whole square. So on simplifying, we get E axial equal to K naught Q 4AD divided by D square minus A square whole square. Now we write this expression as E axial equal to K naught Q into 2A into 2D. 4AD we split into 2A into 2D, or Q into 2A is P, dipole moment, and into 2D divided by D square minus A square whole square. So finally we get E axial equal to K naught P into 2D divided by D square minus A square whole square. So is the final expression of electric field at axial line of the dipole at any point distance d from its midpoint. Now let us talk of discussion, special cases. Now discussion part of it. Since we know E axial is equal to K naught P into 2D divided by D square minus A square whole square. Now when A is very small as compared to D, then dipole behaves as a point dipole. Okay, so this is the first case. Now second case. Since A is very small as compared to D, therefore A can be neglected in denominator. And E axial PD, we write E AX for axial, PD for point dipole. It is equal to K naught P into 2D divided by D4, because we have neglected A. And finally on simplifying, we get it as K naught into 2P divided by D cube. So E axial, when it behaves as a point dipole, that is equal to K naught 2P divided by D cube, and is along the axis of the dipole, that is along the dipole moment vector on the axis of the dipole. Okay, so these are the 2 points of discussion you have to keep in mind. When A is very small as compared to D, then dipole behaves as a point dipole, and for a point dipole, axial field is equal to K naught P 2D divided by D cube, and is along the axis of the dipole. Assignment 1.4, question number 6. An electric dipole of length 0.1 meter consists of two charges of plus minus 500 coulomb. Calculate its electric dipole moment. Also calculate the electric field intensity at a point on the axis of the dipole at a distance of 0.2 meter from positive charge in air. So you solve this numerical problem on the basis of the text that you have learnt. Now continued with assignment 1.4, question number 7. Two point electric charges plus minus 10 microcoulomb are placed 5 mm apart. Calculate electric field intensity at a point on axis of the dipole at a distance of 15 cm from midpoint of the dipole on the side of positive charge. So you solve these questions on the basis of the text that you have learnt. Thank you so much. Tomorrow we'll take up the electric field intensity due to an electric dipole at any point on equatorial line. Thank you once again.